I am going to explain the code that I wrote for the automatic gestures detection. So first, I'll go stepwise, I'll run through the code and I'll explain what each line or what each class or method does. So first, I'm importing all the libraries, that's CV2, NumPy. Just for ease, I'm importing it as NP and I'm importing time. Then I have initialized a class called MP hands. Here I'm importing media pipe as MP because media pipe is a very long word and it's very tedious to write the whole thing when calling the library, which is why I've thought of calling it from a smaller name, that's MP. Then this is the format of how we initialize a class, and so I'm defining init. We have to pass self, the number of hands that it must look for. Right now I'm just doing one. I've added a tolerance of 0.5 and another tolerance of 0.5. So these are two parameters that we need to pass to like when we are detecting hands or when we are recognizing hands, then these are the two parameters that tell about the level of detection to do. Then we are calling self.hands. So basically self is used before what, like if you're calling hands, then we use self so that it understands that it is that particular self or the hand that was initialized above that it's calling. Next I'm calling, so this is again this is a way of calling hands for detecting it. So self.mp.solutions.hands.hands, that's the format. And then I'm passing false. False shows that it is not a static image. I'm passing maximum hands, tolerance 1 and tolerance 2. Then I'm defining another function, marks. I'm passing it self. So there I'm creating an empty array called my hands. I'm converting the image into RGB because only CV2 works with BGR color frame or color scheme. However, the rest of the world, including MediaPipe, works with RGB, which is why I'm converting the frame from BGR to RGB. Next, in the results, I am processing the hands and I'm processing image, the frame RGB because that is what MediaPipe accepts. Next, the data type that we get in the results is a class, and it's a really tough data type or a data set, and it's really hard to understand what it actually means, which is why through these lines I'm just trying to I'm just trying to break that data set down so that I get into the nut. That's the middle part where we actually get the XY coordinates and the width and all. So through these lines I'm just iterating through the results data set, and I'm breaking it so that I get to the nut that is present inside, which is something I really need right now. So first I have a condition, if condition results dot multi-hand landmarks. This is a way of calling it because this is a way of breaking into the complex data set that we have in results. If it's not equal to none, that means there is something in it. Then I'm iterating through it, and here I'm creating a new empty array, my hand, and then I'm iterating through my landmarks.landmark, and then I'm appending the landmark of x and landmark of y, and the value of x and y is generally between 0 and 1, but we need to scale it so that's why I'm multiplying it with width and height respectively, and then I'm appending my hand to the array my hands, and in the end I'm returning my hands. Next up, I have another function, find distances. Now what I'm doing here is that I'm trying to find the distances between all the points of the hand. Now if you all know CV2, then there is this hand landmark chart So here in this function, what I'm mainly doing is that I'm finding the distances between this point to this point, this point, this point, this point, this point, then this with all the others, and then I'm finding for the next point the distance from all the others, and that's basically how I'm doing it. So here row is basically A and column is B. So I'm finding the distance with the formula, a normal formula, hand theta row of 0, like A of 0 minus, so basically x of A minus x of B whole squared plus y of A plus minus y of B whole squared whole square rooted. So here, since I've mentioned float, I am giving it as 1 point and 2 points so that it does not convert it into integer. And here, this is how I'm finding the distance. And then I'm again returning the distance. And this is a generic formula of calculating the distance between 2 points, like from the wrist to the top of the pinky, to the top of the pinky or to the top of the index. So this is the distance. This is how I'm calculating it. And this is going to be a 21 by 21 array. It is going to be two-dimensional because there are total 21 points on this hand. So it's going to be that huge array. And now when I'm finding the error, I'm looking at only the key points. Now, I'll go here and explain this first. So if you see, there are so many points on this hand, and when CV2 sees so many, it's very hard for it to train. So I have used some key points on my hand to train it, and those key points are this point, this, and this, and then the tips of the fingers and the thumb. So the codes, the points for these, for all these 8 points, okay, 1, 2, 3, 4, 5, 6, 7, 8, sorry, for these 10 points is encoded 1, 4, 5, 9, 13, 17, 8, 12, 16, and 20. So these are the points that if you wish to know more about it, then you can go to the hand landmarks chart. There you'll see that this is point 0 and so on. Now here in the find error, so in the previous function, I am getting the whole data set, like the distances between all the points of the hands. But I don't need all of them. I need only the key points, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I need only these many points. So here I'm iterating only through the key points, and then I'm calculating the error. Here I'm taking the absolute value because here we just need to sum up the error and get to know it. We are not concerned with whether it is negative or it is positive. So I'm taking the negative value. And again, row is basically x of A and column is basically x of B. So here row is A and column is B, just for a simple understanding. And I'm calculating the error by adding error, which is 0 initially, plus the absolute value of gesture matrix row and column minus unknown matrix of row and column. Next up, we have the find gesture function. So here basically I have an unknown gesture array, a known gestures array, the key points as I showed you earlier, the gesture names, and a tolerance. I'll explain tolerance in a while. So here basically I'm initializing an error array which is empty initially. Then I'm iterating through the gesture names, and then I'm calling the function find error here. I'm passing the gesture matrix, which is known gesture of A. I'm passing the unknown matrix, which is unknown gesture, and the key points. Here I'm passing I because we want the gesture or the known gesture for I. Whatever we are iterating through at that point, what's that gesture? We need that. And then I'm appending that error to the error array. And then I'm finding the minimum error. So initially I'm just setting the minimum error, so error minimum to the 0th value of the error array, and the min index, the index of the minimum value to also 0. However, later I'm checking whether that is actually the minimum value or not. And if not, then I'm changing it. So I'm iterating through, so I'm using a for loop. I'm iterating through the error array, the length of the error array. And then I'm checking whether the error array of I, so that particular value in that error array, when we're iterating through it, whether that particular value, that is I, is less than error min. So basically it's the minimum error. So if yes, then I think we have found a new minimum value, and that's why we put that into, so we put the error array of I into the error min, so because we have a new minimum value now. And then I'm also setting the index to I, because that's the index where the minimum value is now. Next up, we have this if condition, a simple one, that if the error minimum is less than tolerance, then we initialize a new variable, gesture. We call gesture names. So this is again an array where we'll have all the gesture names, and then we'll put the minimum index, that is I. And if it is greater than the tolerance, then we pass unknown, and in the end we return gesture. Now, to give you a backdrop, like what gesture names are, what tolerance is, I'll explain all that now. So this is the width and height of the frame. This is how I'm calling the camera. Here I'm calling the first class MP hands. Then I have the key points. I'm setting the training to true initially. Then there's the tolerance. I'm setting it to 1500 because I feel that's a fair value, because for some it's in the 5000s and for some it's in the hundreds and 200s and 300s. So I feel that's a fair value. So here, if the error that we get, that's this error, if the error minimum is less than the tolerance, then we'll say that we have a match, that okay, if the error minimum is less than the tolerance, then there's the match, that two hand gestures match. And if it is not less than that, then we say that it does not match. So that's what I'm doing here, and that's the main role of the tolerance. Coming next, here I'm coming down to the next line. We have train count, and we are initializing it to 0, so that we start from we are counting how many trainings we need to do. So I'm starting with 0 and I'm incrementing it down in the code below. Then I have a variable num gesture, where we're just asking how many gestures the user wants to train it on. So here I'm saying how many gestures do you want to train on. I'm asking this to the user. The user will print out something. Then I'm creating an empty array called gesture names and the known gestures, which were the ones I used here, known gestures and gesture names. So these were all that I'm using here, but I'm calling it down. So here it's just a function, so it's not a problem. Then I am asking for the name of the gesture. So it will automatically detect it. So I'm asking for the name of the gesture. So here I'm iterating through the num gestures, and I'm asking it, okay, which gesture, like tell me gesture 1, tell me gesture 2, like this. I am asking the user is going to print that, and I'm appending the gesture name or the name to the empty array gesture names. In the end, I'm printing gesture names. Now coming to this while loop, while true, well, true is always true. So here we are initializing or reading the camera. We are resizing the frame, even though I did it earlier, but yes, we are just resizing it to the width and height. Then hand data, I am finding the hands I'm calling the function marks, which I initialized here. So when I call it, it'll do all the magic. It'll break that huge data set that I get in results, and it will I will go inside, go into the nut and get the x and y value, so that I can do all the magic with that. So just by calling it here, it will do the magic for me. It will synthesize the whole data set, and it will go through it. It will get me the values that I need. Then I have an if condition. If the train is true, and if the hand data set is not equal to empty, then we're printing please gesture, like so here we are basically trying to tell that now please show the gesture this. Like we named some gestures earlier. Now we're telling the user just for training purposes to show that gesture again. So maybe this or maybe this. Like suppose we say go forth and prosper. So we have named this gesture earlier in the gesture names. Now what we're telling the user to do is to show that so that we can train it, or so that the computer can train itself. And then once it has done it, you press T so that you can show your next gesture. That's what we're doing. Then we're initializing a wait key. Then we're finding the distances. Now here again, this is the find distance function that I defined. So I'm just calling it so that I find the distance between between the key points. Next, I'm appending the known gesture to the array known gestures, plural. Then I'm incrementing train count to 1. I'm incrementing train count with 1. And if and whenever train count becomes equals to the num gesture, like the number of gestures the user wants, and if the computer has trained itself to the number equal to the number gestures, then we'll set the train to false. And once that is done, the computer will start predicting the gesture. Now, what to do if train is equals to false? Well, if that is the case, then we will again call unknown gesture. We'll call the find distance function again. And then we'll also call the find gesture function, where we'll pass the unknown gesture, known gesture, key points, the gesture names, and the tolerance. And then when it encounters this, it will go back to the find gesture function and it will run this. And in the end, it will tell me the gesture name. So if the error minimum is less than tolerance, then it will tell me what gesture it is. And if the tolerance is more than that, that means it does not understand it. It will return unknown. So by calling find gesture, here I'm getting the gesture name in the variable my gesture. And in the end, I'm just putting that text, and I'm putting the text on the frame. And then in the end, I'm just showing my webcam